All right, today we are going to be starting a new unit, but we're going to use some of the information, actually a lot of the information that we've been working with over the last couple weeks to help us do that. So today specifically, we are going to be applying the zero product property to solve quadratic equations. So first things first, a quadratic equation is an equation where the highest exponent is a 2. So an example of a quadratic equation could be, I don't know, x squared plus 5x minus 7, or 3x squared minus 2x plus 1, or x squared minus 9. Okay, the highest exponent is going to be a 2. You'll notice that it's still written in standard form with our highest exponent to our constant. Okay, this again is standard form. We've been dealing with standard form as we've rewritten expressions over the last couple weeks. Now, before we actually multiplied out and wrote in standard form, we had an equation or an expression that looks something like this. Okay, x minus 3 times x plus 8. You've seen that a lot over the last couple weeks. This is going to be known as factored form. So it's in factors, where if it's multiplied through, it's standard form. Okay, so factored form versus standard form. Now, over the last couple weeks, we've been dealing with expressions, so something without an equal sign. Now, we're going to deal with equations, right? Quadratic equations, where we have to be able to solve for x. The entire point of an equation is to solve for the variable. Okay, the whole point when you have an equal sign is to solve for the variable. Now, if I ignored this x plus 8, could you solve x minus 3 equals 0? I'm hoping that you're saying yes. I can rewrite this as x minus 3 equals 0, and I can solve for x. So to get x by itself, I would add 3 to both sides, where x equals 3. And I can do the same thing here for x plus 8. I can set x plus 8 equal to 0 and solve where x equals negative 8. These values here are super important. These are going to be the solutions to your quadratic equation. And then when we start to graph, these are going to be where your graph crosses the x-axis. So there's solutions to your quadratic equation, and then as we start to graph, it's going to be where your graph crosses the x-axis. Those are going to be important values as we move forward. All right, a little bit of notation before we fully get into this. Function notation you should have seen before. Function notation is something where we have f of x equals, and f of x is the same thing as y. It's just a different way to write it. Okay, so f of x and y are exactly the same thing. So I can write f of x equals 2x plus 5, or I can write y equals 2x plus 5. Okay, it means the same thing. The difference is typically when we use function notation, we are going to plug a value in this case for x. Okay, that's typically when we see the difference, but just know that you could see both of those notations and it's going to mean the same thing. Okay. So up here I told you that these two values were the solutions to your quadratic equation. It's where your quadratic crosses, or your graph's going to cross the x-axis. They're also known as zeros. So we're going to find the zeros. Okay, so they're also known as zeros. So we're going to find the zeros, and we're going to write the equation in standard form. Actually, I lied. We're not going to write the equation in standard form. So sorry if you have to delete that. We're going to delete that. We're just going to worry about the zeros since I'm not here today, and we'll worry about the rest later. Plus, we've also spent a lot of time already writing in standard form. Okay, so when you're asked to find the zeros, that just means you're going to solve for the variable. So if you're asked to find the zeros, you're going to solve for the variable, and we're going to solve for the variable using the zero product property. Okay. I'm going to let you catch up on writing for a second. So we're going to find the zeros. We're going to solve for the variable using the zero product property. So let's look at f of x equals x minus 15 times x plus 7. So right now I'm in function notation, and I can't solve anything because of this f of x. However, if I'm using the zero product property, I can set this f of x, or that y, equal to 0. Now the reason that works is because if you look at a graph, I'm going to move this for a second. If I look at a graph and I'm telling you that when I solve, that's where my quadratic equation crosses the x-axis. So for instance, it's going to look something like this eventually. Okay, so if these 2 points is what I'm solving for, that's where it crosses the x-axis. So let's just say this is a 3. What's the value of y? You should say 0. And let's say this is negative 2. What's the value of y? 0. So we're allowed to plug in 0 for y, or f of x, in order to find those zeros and figure out where we're going to cross the x-axis. So that's why we're setting the entire equation equal to 0. Okay, so we have 0 equals x minus 15 times x plus 7. And you're going to take each of those just like we did up here and set them equal to 0. So x minus 15 equals 0, x plus 7 equals 0, and we're going to solve. So I'm going to add 15 to both sides, and I'm going to subtract 7 from both sides. So x equals 15, and x equals negative 7. Now some of you can probably skip this step and go from writing it to here, but I do expect you to write it out and set it equal to 0 and then give me an answer. So these are your zeros. Okay, so you can skip this step, but I do expect to see everything else until we are really good at it. Because there are going to be times where it's not going to work out as nicely and we might have fractions to deal with. So yeah. Okay, so let's look at the second one. So 2x plus 1 times x minus 7 equals 0. So I'm already setting this one equal to 0. But again, if it's f of x, you can set it equal to 0 on your own. Okay. So I'm going to take each of these factors and set it equal to 0. 2x plus 1 equals 0, and x minus 7 equals 0. You're going to start with this one. So if I want to get x by itself, I'm going to subtract 1 from both sides. So 2x equals negative 1. And then I'm going to divide by 2. So x equals negative 1/2. And then up here, I'm going to add 7. And x equals positive 7. These are my zeros. Okay, so you're setting each of those factors equal to 0. I'm going to give you another 2 examples, and then I'm going to have you try 2 on your own. And I know I'm going through this quickly, so if you need to pause and rewatch, it's also up on Google Classroom so that you can rewatch the video as well. So here I'm going to give you 7 times x minus 13 times x plus 12 equals 0. Now you should notice 3 different factors. You have 7, you have x plus 13, and you have x plus 12. We're going to set each of those equal to 0 to solve. And I want you to notice something. So in these 2 problems, you can solve for x. So let's do that first. So I'm going to subtract 12 and x equals negative 12. I'm going to add 13 and x equals positive 13. But here, there's nothing to solve for. Does the statement 7 equals 0 equals 0, is that statement true? That's what I'm trying to say. Is 7 equals 0 a true statement? Does 7 equal 0? Hopefully you're answering no, which means we can't even use that. Okay, so if it's just a constant out here, you don't really need to set it to 0 because it's not going to work anyway. Only if it's a constant. Okay, because 7 does not equal 0. However, if I have 3x times x plus 5 equals 0, how many factors there do you see? How many factors do you see for 3x times x plus 5 equals 0? You should see 3x equals 0, and you should see x plus 5 equals 0. And in both cases, you can solve for x. The goal is to get x by itself. So let's start here because this is one we've seen a lot. So I'm going to subtract 5 from both sides. X equals negative 5. And what do I do here to get 0 by its, or to get x by itself? So I'm multiplying 3 times x, which means I'm going to divide by 3. X equals 0 divided by 3 is 0. It will be nothing else other than 0. So these are your zeros, or where it crosses the x-axis. Let me add it over here too. Okay, so at this time, this would be a good time, as soon as I write down these questions, to pause the video so that you have a second to try them on your own. So the first one is going to be 5x times 2x minus 1 times x plus 1 equals 0. And x plus 3 times x plus 3 equals 0. So pause the video at this time and try these 2 problems. As soon as you're all ready, go ahead and play the video and I'm going to go over it. Now that you've had a chance to work out the problems, I'm going to go through it quickly because you, again, should have already tried. So let's do number 5. I see 3 factors I'm going to set it equal to. So 5x equals 0. 2x minus 1 equals 0, and x plus 1 equals 0. So if I want x by itself here, I'm going to divide by 5, where x equals 0. For this one, I'm going to add 1, so 2x equals 1, and then divide by 2, which means x equals 1/2. And on this last one, I'm going to subtract 1 from both sides, giving me x equals 1. So my answers are x equals 0, x equals 1/2, and x equals negative 1. For number 6, I'm going to take x plus 3 and set it equal to 0, and x plus 3 and set it equal to 0. If I subtract 3 from both sides, I get x equals negative 3, and x equals negative 3. Now technically, we only need to write this once, because it's the same, which means on our graph, that graph is only going to touch the x-axis once. If you have both, that's fine, but you really only have to write it one time. Okay, at this time, you are going to go onto Google Classroom and you are going to complete your homework assignment. Once you are done with that, I have an activity that you need to start working on, which will help us as we start factoring tomorrow. You're going to struggle through it maybe a little bit until you find the pattern, but once you find the pattern, you should be good to go. I will be back tomorrow and I will go over any questions that we still have.